So I'm going to start with a little bit of history, and then I'll chuck in some physics if we want some lessons this morning. Exploration of Africa by Europeans in the beginning. So the first adventurers who traveled to Africa from Europe, they wanted to discover new things. They wanted to discover the source of the River Nile. They wanted to learn more about this continent of Africa that they were visiting. Essentially, they were traders, and they wanted to explore the interior of Africa and find what natural resources they could find and take back in the interior of Africa. So James Bruce was one of the first explorers that came to Africa in 1730 to 94. He was a Scottish explorer, and he was setting off from Cairo looking for the source of the River Nile. And he got as far as Lake Tana in 1770, and he discovered that was the source. He established that was the origin of the Blue Nile. John Speke, again, went on a similar journey. He was looking for the source of the Nile. And in 1856, he reached Ujiji on the shores of Lake Tanganyika. He got there and he found that the local people told him it wasn't the source of the Nile. And then he traveled a bit further, and he got to find the waterfalls at the end of Lake Victoria. And he was convinced that was the source of the River Nile, but he wasn't unable to prove it. So he traveled northwards along the Nile, and then he reached England. He published articles about his journeys in East Africa. So yeah, further explorations carried on, and Henry Morton Stanley was one of the most famous British explorers, and he traveled across Africa, came to East Africa from the south looking for David Livingstone, who disappeared. He traveled 700 kilometers through tropical forests, and he hoped that the journey would bring him fame and wealth and make him his fortune. And he found Livingstone in 1871 in Ujiji again, and he came back and wrote a book to describe his adventures in Central Africa. Now, he returned back to Africa in 1873, and then he came into Dar es Salaam, which is interesting that and then traveled across from the east to west of Africa, passing through the Great Lakes and into the Congo and across the Congo Basin. But he went back to London and he wrote a book which was called Through the Dark Continent, and it was the Evening Standard, the British newspaper, who chronicled his journeys, and they first termed this term Cape to Cairo. But following that, it was then Cecil Rhodes who saw this as his vision to build a railway all the way from Cape Town to Cairo. He wanted to have a British-controlled corridor all the way through Africa, north to south. He never finished that journey. He never finished that project. But a lot of sections of what Cecil Rhodes was trying to build were completed around that time. Going back. So yeah, the Lunatic Express. So again, this time, so the colonial controlling Africa, where they were building infrastructure across all over the place at the time. So one story is the railway, which was built from Mombasa all the way to Uganda on the shores of Victoria. So this is the time, they cost an awful lot of money, around $1.6 million pounds, and that essentially was almost a trade subsidy. So although it was investment from the British government, they were using this railway to extract minerals and other things out of the center of Africa. So it effectively was a trade subsidy, just like we're seeing now with other investors in Africa that are coming from. So Africa is no longer a dark continent, but it is really big. So the map on the right, I think probably a lot of people have seen it a lot. I just remind, is showing all the countries that can fit into continental Africa. So you have China, you have the United States, you have India, all fitting into the same landmass, plus a bunch of other countries. So it really is large. And this is one of the big challenges as to why some of these infrastructures have not been completed north, south, east, west in Africa. You also see on the left, you see satellite imagery of Africa at night. So there's a lot of bright lights you can see in West Africa, East Africa. Even South Africa has got a lot of dark spots. It's a very big country, very dense metropolitan areas. But really massive, massive dark areas, the Sahara Desert, all through the Congo. which are really geographic barriers separating Africa into effectively almost three zones, in having West Africa, North Africa, and Southern and Central Africa, Eastern, Southern, Central Africa. We made some predictions in 2012 around how the internet might look in 2022. Around 2012, we'd been relying upon satellite communications, and they'd been typically connecting from a landing station in your main city, connecting to Europe, somewhere in Germany, UK, to give internet and voice connectivity to the rest of the world. But subsea cables had come in around 2008, 2009. But still, everybody who was using these subsea cables was using them to effectively connect one long line straight to Europe, normally to London, and sometimes in Southern Europe as well. So the African internet looked like the picture on the left, which was exactly like it did in the satellite days, except instead of all the lines going to a satellite, all the lines were going to London. We predicted that African internet by 2022 would be a fully meshed, interconnected network, and having internet exchange points in every main city and in other smaller cities as well. Less reliance upon subsea capacity, and having more interconnection and more content being distributed and consumed by the African internet on the African. So yeah, so predicted that the African will be more interconnected and not having straight connectivity back to Europe. This is data from 2018. This is presented by Telegeography at AFPIF in Cape Town. And it shows a picture which is slightly more capacity on the network, but very similar to as it was in 2018. So the circles and the diagram on the left, they are showing the data consumption by country. So South Africa is the biggest data consumer in Africa, followed by Morocco. And then you have Kenya as well there, and Nigeria as being large consumers of data. The red lines between the countries. So what you're seeing there is on the west, there's hardly any interconnection between the countries. In the north, none whatsoever. But on the southern, east, and central Africa, you're seeing a lot of interconnectivity between countries. You're seeing South Africa as being a very large connectivity hub for all of Africa. You're seeing Nairobi as also being an emerging hub, very big links between Kenya and South Africa, Kenya and Tanzania, and all these other countries. Djibouti as well, having, because of its strategic location, having a lot of interconnection of cables, being a point of interconnection, although not having very big links, having a lot of links to different countries, because it's generally the main termination point for the easy cable, where the other cables to Europe are connecting. We also see a trend of data prices of that international capacity dropping absolutely sharper than anywhere else in the world. So back in 2014, a 10 gigabit wavelength to South Africa was around $250,000 a month. It's dropped now to below 50,000. But you see, compared to the other being much more expensive, and now the capacity to South Africa is reaching, getting close to the same sort of prices as we see in Latin America. Now, if you're questioning why that's relevant, we see that the price of bandwidth across all of Africa tracks what happens in South Africa. It's a bit more expensive, but let's say that if the price in Kenya might be about 2 times the price in South Africa, the price in Tanzania might be between 2 and 3 times the price in South Africa. So all tracking the same model of the bandwidth cost falling. Ultimately, the driver behind this is the more, all the cables that are servicing, the countries as you go along on the west and east coast, all getting to South Africa, apart from ACE. And as there's more utilization on the cable, that is driving down the price of bandwidth on the cable. But we see high cross connection charges and other fees to get inland as being on a lot of the smaller countries, as then making the price more expensive than it is. So broadband networks and connectivity across Africa tends to follow road, rail, and port networks. So it's infrastructure, physical infrastructure that is already there existing. So on the right-hand side, you see the network of subsea cables, and this is a very well-used diagram, but it's showing how the subsea cables connect across Africa and down the coast. But the data flows that we've seen are not following those routes, even though those cables have been constructed on those routes to connect as many countries as possible in consortium models, or to get as many customers for a private cable. And the data flows are not entirely following those routes. What we see on the physical infrastructure map on the left is showing, the road, rail, the ports. These are the infrastructure that is facilitating movement of trade, movement of people. So if you have a road, you have a railway, you have movement of goods. It's been there for a reason. So it's been built for a reason, and it's going to be used in some way. So where you have movement of goods and information, you have trade, and that basically arises to moving in data. So if you have movement of information, you have movement in data. So that is why the actual usage is following those things. Of course, the fiber infrastructure that's carrying most of this data is also built on the same corridors. So we tend to build our infrastructure, our fiber, on a road or a railway because it gives you a safe passage, a way leave across long distances that you can build a fiber and maintain the fiber going forwards. So I've promised a bit of laws of physics. So the laws of physics, basically, they haven't changed for a few hundred years. Isaac Newton there on the left, and in the 17th century, he wrote down all of the laws of physics, or the laws of time and motion if you're sitting under a tree. There next to him is Albert Einstein, who revised the laws of time and motion if you are sitting next to a black hole or on a spaceship. And underneath them is Captain Scott in the 23rd century. He was the first engineer to realize you can't change the laws of physics. But the speed of light in a vacuum is fixed as a constant. Glass, which is used for fiber optic networks, that has a refractive index. And then you put that together, you see that the latency, the round trip delay on a network is around 1,000 times 2, the return journey, times the distance, divided by around 200 million to get the latency figure. So I promised a few journeys, so let's take a few. So Cape to Cairo is the subject of this presentation. If you apply the laws of physics, Cape to Cairo should be around 97 milliseconds for a ping for packet to go back and forth. It's just over 10,000 kilometers, and the road, the route that Google gives you is pretty much infrastructure and roadway that's been there for centuries, and there is in fact fiber optic network through most of that route, though it passes a slightly different way. There's not really any fiber optic infrastructure through South Sudan. It's just been, and still is, having a conflict, and they haven't finished the fiber networks there. So the fiber optic networks that are on this route are a little bit to the east of that line, going through Kenya. So let's see how the packet goes. The packet starts in Cape Town, and then it goes to London. Then it goes to Palermo on the southern coast of Italy, to Cairo, and all the way back again, to make the latency 209 milliseconds. It's around about double what it should be, around about double what the laws of physics are telling you. But that's a relatively straightforward one. I've done a few of these illustrations here. So Mombasa to Kinshasa, it's really not very far. It's only about 4,000 kilometers across Africa. Packet starts in Mombasa, goes up to southern Europe, to Marseille, to London, to Kinshasa, and then all the way back again, making it around about 296 milliseconds. So that is almost 8 times longer than the journey should take, and traveling many thousands of kilometers further. Djibouti to Douala, another cross Africa route. This one starts in Djibouti, goes to Marseille, and then goes across to Italy, to Milan, Paris, London, Spain, Cameroon, and back again. No, see, Nigeria, then Cameroon. So one thing that's interesting to note here is that Nigeria potentially could emerge as a connectivity hub for West Africa. So on this journey, the packets are traveling and actually hopping in Nigeria. So it's showing that it's starting to become potentially a regional hub. But really, the journey around Europe is showing how, the interconnection, even the African interconnection networks, are not even finding a common place in Europe to interconnect. They have to travel around to various different countries before they get back to Africa. That then 202 milliseconds, around about four times what it should take. Cape to Casablanca, it's a pretty similar story to Cape to Cairo. Again, coming up via London. This one is taking a longer journey across Europe, going to Paris, and then traveling through Spain, where the cable landing stations go to North Africa. So here, the peering is, or the interconnection is taking place perhaps in France. You've got French-speaking countries and Europe and English-speaking countries not having a common place where they'll be exchanging their traffic. So that packet goes back again is around about 192 milliseconds. It's about twice what the laws of physics are telling you it should take. The Osaka to Lagos, I'm gonna flip through this one rather quickly, but that should be 54 milliseconds. It's really not very far. 299 milliseconds, so about six times what it should take. Again, going up by Europe, by Frankfurt, and coming back to Africa. Now, this is a really good one. I've added this one, and as a reason for adding this one. But Cape Town to Khartoum, I've used a bigger map there. You'll understand why in a second. So packet starts in Cape Town, travels up to London, goes across to New York City, San Jose, and across the Pacific Ocean, all the way to Tokyo, Hong Kong, Mumbai. Now we're onto the flag cable system. So Port Sudan is connected on although it's connected on easy, it hasn't used much of its easy capacity, and largely is using a lot of the European cables and the cables to Saudi Arabia. So the flag Falcon cable system, which is owned by Global Cloud Exchange, is connecting Europe to Asia. I think this is one of the reasons it's using this particular route. And then traveling to Dubai before getting back to Khartoum. So this should be 84 milliseconds, and this is, I think, one of the worst examples. But it's a 450 milliseconds. It's around about almost the speed of satellite. So satellite would have been around 525 milliseconds latency, and this is getting on for just slightly underneath that. Despite the fact that the infrastructure exists. So the easy cable connects all the way down from South Africa, all the countries on the eastern coast, and all the way up to Khartoum. And as I said, terrestrial fiber exists and has existed for some time with networks that are there, terrestrial and submarine networks connecting to East Africa, and then networks of Ethiopia Telecom, Telecom Egypt, and Sudatel. And now this is my favorite one, I thought I was just picking names of letters that, countries or cities that started with the same letter. So I picked Maputo to Madagascar. I thought it's not very far. It's about 800 kilometers. Except I went on Google Maps. You've seen I've used Google to find a route on every other thing. Google couldn't find a way there. So if the internet couldn't tell me the answer, I picked up a book and I picked up the Lonely Planet Guide. And that told me that there are no direct flights from Maputo to Madagascar, and there are no passenger boats from Maputo to Madagascar. The only way you can get there is to go and hang around the port, talk to some fishermen or some trading vessels, and see if you can hitchhike a ride on some kind of freight ship or boat that's going to be traveling to Madagascar. So this one starts in Madagascar, goes to Johannesburg, to Cape Town, to London, Paris, down to Madagascar. So again, coming back, London, Paris, can't exactly decide where it wants to connect in Europe. So that then travels all the way back again, making the latency for the whole trip 589 milliseconds, so more than satellite. So this is actually the closest journey, the shortest journey I've taken here, but it's actually taken the longest. So really, we're not quite making sense with the way that we are routing and connecting our internet traffic. The infrastructure is there. We've been talking a lot over the last 10 years about building infrastructure, but it's already there. So content has been coming. So content has been coming to Africa, and we see the big names of the global internet world. We see Google, Netflix, Akamai, Facebook, all been putting into their POPs, their edge nodes into Africa and putting their traffic close to the user. But Microsoft are the first who have announced a large cloud deployment. So they put a large Azure data center for their cloud services, both into Cape Town and into Johannesburg. So this is, I think, the largest investment by a North American company in African internet infrastructure by far. Although they may not have made the most noise about it, some of the others have made more noise. But it's changing the way that that we will be accessing the cloud. So more other cloud players are coming, and you've seen announcements and noises from Amazon Web Services about opening up cloud in Johannesburg. And we've also seen Jack Ma visiting Africa twice in the last year. He's not just coming for safari; he's obviously coming for a reason. So with cloud, with the content and with the caching and the content being on Africa, and then the cloud being on Africa, it's going to reduce our reliance upon the connectivity to Europe and having a more interconnected Africa. For the terrestrial networks, where are we on the journey to 2022? So, the networks are there, the subsea are there. The subsea is still carrying most of the traffic, even on up the East Coast. You saw those big trunks between Nairobi and Johannesburg. They are mostly being carried by the subsea networks, and even us as Liquid Telecom, though we have terrestrial fiber and we lease some fiber on some of those routes, particularly through Tanzania. We don't own the fiber in Tanzania; it's owned by the government and leased. So the cost of some of these, leased networks make it not effective for us to use those terrestrial networks, and we prefer to use the Easy cable and the Seacom cable to connect up between our major hubs. The pricing of bandwidth is coming lower and lower. Again, it's tracking South Africa. South Africa is approaching Latin America pricing. Internet hubbing within Africa is really taking place in Johannesburg, Nairobi, and a bit in Southern Europe, in Marseille. It used to be taking place in London, but it's now shifting halfway between Marseille and London. And most countries have got a fiber network. I mentioned South Sudan hasn't, but there have been a combination of privately driven projects from people like Liquid Telecom and some mobile networks. Facebook have had a go at building fiber, and Google have built metro fiber. But governments, either Chinese funded or World Bank funded, have also been building national fiber networks. So most countries have got a fiber network, and most of these fiber networks do have a interconnection to the border. The government-owned network in Tanzania, I think, has interconnection to 7 country borders, which is the most of a national backbone network. It's got the most borders, and it could be, by that qualification, could be Tanzania could be the hub for East Africa and for Africa, because it's the most interconnected country with other countries. But again, it's the price and the quality and the reliability of the network is holding it back from achieving that position. Most countries have got local internet exchange points. There are multi-site exchanges in South Africa, in Durban, Cape Town, and Johannesburg, which are connecting up different areas and different data centers in the cities, just like the European exchange is allowing you to peer without having to buy transport across from one place to the other. You can have one port in the data center you're at, and you can connect just a flat fee for the peering port to anybody else who's in another data center. The fully meshed terrestrial internet, has only emerged in the SADC region and East African Community region. In West Africa, we saw, there was some connectivity between Nigeria and Ghana, but there's not really much interconnectivity between countries. Cross-border peering is not taking place for peering's sake. And what I mean by that is that where cross-border interconnects are there, they're being used to sell services to a neighboring country. So if one country has a landing station, and then there is a landlocked country, it is using the cross-border interconnect to sell IP transit to that country. This leaves some of the landlocked countries feeling disadvantaged, but also some other landlocked countries feeling advantaged. So a country like Rwanda is able to connect to Uganda and Tanzania, is able to play off the bandwidth pricing between the two countries and bring down the cost of Rwanda, the bandwidth in Rwanda, to being even cheaper than it is in Tanzania, which has landing stations. So the backbone companies are there, and there are a number of different companies having large backbones and having Pan-African networks, and the content is coming and keeps coming as well. So what is driving all of this? To travel across the border, it's basically a process. So you just basically need to have valid documents, payment for your tickets. You might need health documents, passport, and you've got to have a reason to go. Why are you traveling? Why are you traveling across the border? And I use the same analogy to say, if you're building a network across a border, you've got to have a similar set of criteria. You've got to have a valid license to operate either side of the border, just like you need a passport. You've got to have a means of crossing the border. That will be the road, rail, the infrastructure, the overhead lines, or some undersea cable that is there. You need some permissions and other permits to cross the border. Maybe visas, as I say, and yellow fever certificates. And we have respective companies on either side. But if you're having an interconnection relationship with somebody else, they need to have a reason to interconnect with each other. So are they buying services, selling services, or are they just going to be doing it for peering's sake? So it is that reason to cross the border which has held back the uptake and use in some of these in some of the border links. There seemingly no consumer demand or business case to use it. So for us, we've had no reason to use large amounts of capacity between Tanzania and Zambia, because it's cheaper for us, much cheaper for us to use the subsea cable networks. Infrastructure mega projects have been driving expansion of the connectivity. We're seeing, there've been some projects from the World Bank, but we're seeing very, very large investments coming from China at the moment. A new railway connecting from Djibouti to Addis Ababa. We're seeing Lapset corridor across the northern Kenya, connecting or trying to connect into Ethiopia and Sudan, pipelines and road and rail. A new road has been constructed from Kenya up to Moyale to the border. Power lines are being added as well. So at Liquid Telecom, we try and use the infrastructure projects that are taking place as complementary infrastructure to roll out fiber networks. But of course, the one challenge is that we need to move fast in building out the network across Africa, and some of these infrastructure projects take too long, and they take a long time in negotiations, raising funding, and ultimately, we find other ways sometimes if the projects take too long. Digital transformation of Africa is really where we're going. So, as I said, we're having cloud connectivity. Cloud is coming to Africa, but the connectivity has been reliable enough to. We're saying that Africa has been cloud ready since 2015. Now, that is a combination of the connectivity being reliable enough to use the cloud. That's connectivity from the major landing stations to the main cities, and then distribution networks to the businesses, to the buildings that are there, so that you can have a solid, reliable network. You don't have to have your email server on your premises. And the applications themselves as well. Those are that made a big difference. Applications of progressive operating systems and office systems becoming more and more usable if you're using high latency links. So we still had cloud being hosted in Europe, but as the applications have got more usable and less susceptible to problems caused by those delays, it means that we're using the cloud a lot more. So following the cloud, following investments in cloud coming to Africa, we're seeing transformational, what IDC are calling the fourth industrial revolution. Technologies like data science, Internet of Things, e-commerce, mobile apps, trust-based services like Uber, are coming up and making a difference in the way we do business and the way we live our lives. Media and gaming as well. So, a large driver of internet traffic and capacity is online entertainment, Netflix and other services. We're seeing, again here in Tanzania, quite low mobile data prices. And, really a lot of different IPTV services, online music services are really driving people to use the internet for that. And gaming as well, internet gaming, both mobile and console based, but really predominantly mobile in Africa is really driving things forward. The Africa Free Trade Agreement happened this year. So Africa at the moment has a really low level of intra-African trade. So of all the trade Africa does, only 10% of that is with its other African countries. Whereas the number in Europe and North America is much higher than that. It's more like 30 to 40% of intracontinental trade. So the deal that was announced this year I think it was about 40 or so of the 54 African countries announced this free Africa trade agreement. This potentially brings together a common market of around 1.2 billion people, which is expanding rapidly, and a GDP of around $3.4 trillion. So this can make a huge difference to, again, the movement of trade, the movement of goods, the movement of information, which is driving the need for broadband networks. Africa's rising youth. We wrote a report about the African Generation Z earlier this year. So, basically, children, teenagers, youngsters, they are now, if you're giving them access to connectivity, access to devices, they're living in a digital life. So we are also having a hugely expanding youth population across Africa. And basically, Africa is going to have 1 billion digital natives in a few years' time. So this is really going to drive the need for connectivity. At the AFPIF conference I was at the other week, one of the presenters even suggested that internet traffic in Africa could even outstrip that you have in North America and Europe, just by virtue of the population. And that would be an impressive thing to see. And Internet of Things. This picture on the right is actually from Tanzania. So it's a makerspace a few 30 kilometers or so out of Dar es Salaam. And this is a water dispenser, but it's an internet connected water dispenser. So IoT enabled. They put in connectivity there so that it's designed for dispensing water. You're using a coin mech machine, but the IoT element of it is these are putting in rural areas, but it's communicating back to the person who's leasing the machine, to the community who's built the machine, to say how much takings have come in there, to make sure you can monitor the water usage and the revenue collected by the machine. But a whole load of applications for IoT, agriculture, health, smart cities, transportation. Really, IoT has the potential to solve a number of business problems and even social problems and have a great contribution by collecting information. It connects the physical world with the internet world so that we can use this data and start doing analytics to make a difference. And Africa has no shortage of issues to solve. In Kenya, there's around about 1 million IoT devices at the moment and population around 45 million people. Globally, the number of connected things has already exceeded the number of people by quite a long way. So there's around about 10 billion connected things to about 6 billion people. So, you can see that on the IoT, Africa is very far behind. Really, a country like Kenya should be getting very fast to 45 million connected devices. You should be getting back on that trend. South Africa is more mature on an IoT. And there are several networks that are delivering IoT connectivity in South Africa. We've just announced an IoT network in Kenya, and we're expecting that to drive the adoption. So this is our vision of the future. Somebody used this term last time I presented it, and they used this term end-to-data colonialism, which I thought was quite interesting. Infrastructure growth. So we've announced Cape to Cairo, north to south in 2018. But we're expecting to see multiple routes crossing east to west by 2020, following networks that are already there and not really being used. So you see there lines crossing all the way from the landing stations in DRC, crossing Kinshasa and Lubumbashi into Zambia. That existing fiber has been there now for I think almost 6 years, and a project built by the World Bank. They built overhead power lines from Inga Dam to Kolwezi. And still to this date, really, the fiber part hasn't been used. They did run a tender, which took several years, and we, among other operators, answered. But, it's still now having finished that, and they go to test the fiber, and it's not even working. So, really sad to see infrastructure being delayed in its adoption, and then even falling into repair before it's ever being operated. So, but a combination of the expansion is going to happen by the combination of investments from private sector and public sector operators. We're going to continue to build fiber optic networks, but we're also moving towards partnering with existing fixed line networks. So in establishing Cape to Cairo, we've partnered with Ethiopia Telecom, Sudatel, Telecom Egypt to complete that route, not building fiber in these countries. So it's completing a single journey. A West African hub will have to emerge. So, it ought to be Lagos. So the reason it ought to be Lagos is because Lagos has this huge population. 1 in 5 Africans is Nigerian. So if you're investing in data centers in cloud technology and you're going to put that into a country in West Africa, Nigeria is the obvious location because you've got the biggest volume of consumers. But still, we've not yet seen, Lagos hasn't yet become a connectivity hub, but let's see if it does. But, you could get connectivity hubs in Ghana, Cameroon, Cote d'Ivoire, could also become, a West African hub. So outcomes of where we're going, we're looking at digital transformation of Africa's businesses, public sector, and driving a shift to the cloud. Africa's youth population, 1 billion digital natives, 1 billion things connected. That's what I'd like to see. So population of Africa, over 1 billion now. Let's have 1 billion IoT devices in Africa. African trade agreement is driving intra-African trade. And I found some interesting data around the top banks in Africa. So of the top 14 banks in Africa, all of them are in 4 countries, in South Africa, Egypt, Morocco, and Nigeria. And of the top 40, I think about 80% of the top 40 were in those countries as well. So, we're seeing the banking centers connecting currently via Europe. And we need to have a more interconnected banking and trading and stock market ecosystem. So I'm just going to, this last trace is just showing some of the improvements. I talked earlier about Cape Town to Khartoum. We have announced and completed the One Africa broadband network. We have reached Cairo, but we're unable to show data traffic going to Cairo at the moment. But the link is present and tested all the way to Cairo. But I'll show the difference it makes from Cape Town to Khartoum. So the packet starts in Cape Town here, travels to Johannesburg, then goes to Bulawayo in Zimbabwe, across Victoria Falls Bridge to Livingstone, and then to Lusaka in Zambia, then to Dar es Salaam. So it's not quite taking the shortest path, but it's taking a path slightly to the east of the shortest path. Then up through Kenya to Nairobi, into Ethiopia, and to Khartoum. And then all the way back again, making 120 milliseconds. So we've shaved around, we've reduced the latency by about 75%, not traveling all the way around the world via Hong Kong. So I think I'll end on that note. I can play a little video if I can get it to work.
Much, Ben. So we have any questions concerning the presentation? Very interesting. Cape to Cairo.
My name is Nishal. Fantastic talk, Ben. Great visuals, as always. It was wonderful to see the updated parts that you showed, the Khartoum part, and congratulations to you and your team for what you've done with the connectivity to Khartoum. I can't wait for you to get to Egypt personally. Well done. There was one data point that you mentioned in your talk that I'm curious about. You said that the price of bandwidth in Rwanda is cheaper than what it is in Dar es Salaam right now. It's cheaper to get, because of the consortium bills, I guess, that they are picking up bandwidth from the landing stations cheaper than here. Could you tell us a little more about that? I mean, I'm curious.
Yeah.
This is Tanzania. So what do you think's behind that?
I think now it might have got a bit less in Tanzania, but ultimately Rwanda had this position of being interconnected to multiple borders. So it was connected to Tanzania, it was connected to Uganda, and Uganda being interconnected to Kenya. So Rwanda as a nation put together a tender, or it was a World Bank driven initiative where they wanted to buy some IRUs of capacity. So the government of Rwanda basically bought IRUs of capacity. Ran a tender to do that. So what you had was you had a single operator a single backbone operator in Tanzania, which had quite high and restricted prices. They have come down now since then, I will say. But you had a few operators in Tanzania who had access to that. It was an open access, is still an open access network at least. So you had a few different operators from the Tanzanian side, and you had a few different operators that were able to connect to Rwanda on the northern side of Kenya, Uganda. There was KDN, Liquid Telecom, and MTN Group, and others. So they managed to run a tender, get the price of bandwidth down. They were able to buy bandwidth cheaper than Tanzania was able to offer, and even cheaper than the price was in Tanzania. And now that was bandwidth bought by the government for government consumption, but the government, by establishing its own backbone network, which could sell capacity, that effectively set a capacity price within the country. So, although most capacity is delivered by private operators, the initial peg on bandwidth was driven by the government, whereas in other nations that have been in other landlocked countries, maybe the price has been set by the operator.
So as a follow-up to that, would you consider the larger portion of that? I mean, obviously the government played a huge role in that, but would you attribute the price cuts to the creation of competition from having other multiple operators and multiple options? You mentioned Rwanda could get bandwidth from different areas, because it's certainly not a volume. I mean, there's two things that would drive prices down. Yeah. It's competition or volume. And it couldn't be volume because they don't have access. They would not have access to that raw band.
Entirely competition. So, and I did in Tanzania's credit here, I mentioned that the data prices in Tanzania are lower than a lot of other countries, and are lower than South Africa even, Michelle. And that's changed the way that the consumer is behaving. And I say there's people sitting on the bus and they'll be streaming YouTube videos instead of listening to the radio. And that is arising from, you had Vodacom being there, but you also had Viettel building a network across the country at the same time as Tigo was coming in aggressively. And so you had two new operators coming in and jostling for market share at the same time. And an incumbent there who had a bigger market share. So that competition totally drove down the data price. Even though the wholesale data costs were a little bit on the high side at that time, but ultimately the wholesale data cost, and we moan about it so much, but it's now become a very small portion of the overall cost of data delivery. It used to be, when we started out as Liquid Telecom, it was around 70% of an ISP's costs. It's now probably 20 or 30 in terms of its cost of sales. But the price came down because of competition, and really it's only competition and or effective government intervention is going to make a difference.
I'm Eric Roberg. Thank you. Very interesting talk. On your last route, it was coming up through Tanzania and I believe it was crossing Namanga. Is that, I know it's operational, but is it reliable? And also Hulili.
We have fiber optic road routes on Kenyan side to Namanga, and then there's also an option for a backup capacity. We've signed an agreement with the distribution company in Kenya, so we can have capacity to Namanga, a very reliable link to Namanga, basically from Nairobi. However, we suffer a lot of challenges with the NICTPB link from Arusha to Namanga, and not one you can rely upon. We use it as part of our East African ring, but we use most of our capacity from Nairobi from Kenya to Dar es Salaam. We use
Bob here. A quick question. You might respond, but I would like to hear your view. I'm sure you're aware about the Smart Africa initiative, especially
What, sorry?
the Smart Africa initiatives around One Africa Area Network and a clearinghouse for Africa. And looking at some of the, the traffic behavior that you illustrated, how feasible is it technically to actually achieve an intra-Africa clearinghouse that ensures, or that sort of ensure that all traffic that is not meant to go out of Africa does not go out of Africa?
A clearinghouse is a voice concept. So it's to do with trading of voice. When you're operators trade voice minutes in a certain way, where you pay, the originating party pays and the terminating party charges. Now that has complications, and has been good for Africa in some and many ways. ITU put a lot of these principles in place at the beginning, and this enabled Africa to charge very high prices for international phone calls into Africa. It enabled a lot of the incumbent telcos who originally had gateway licenses to profit and to make money and raise international currency on international incoming voice. And even Liquid Telecom, we started out as a voice operator and they'll have a very big voice business. That then, with this internet thing that we are here talking about, you then got into voice over IP, which is then often used to bypass carrier tolls, and a lot of pushback and fight has been against that. But GSM roaming has ended up, because of various different dynamics around this and high keeping international call rates, internal call rates high, operators and regulators keeping those high so as to raise foreign funds coming in to pay for international. That has a negative effect, had a negative effect on intra-African roaming charges, and has a terrible effect on intra-African voice quality. It's very bad calling on a mobile phone. And the pictures I showed you, of packets going to Europe, don't be surprised if they do the same for voice calls. That is even compounded because when you have a voice call, it's being compressed and decompressed a lot. So a lot of, if I'm calling from Kenya to Uganda, to MTN in Uganda, I shouldn't be surprised. Those voice minutes are changed to India, been decompressed. So I think the One Africa initiative is really focused on roaming, and it's very important. The European Union made massive cuts on roaming data charges in Europe. Roaming data is very expensive in Europe. And if you can go to another country, if you can travel from Kenya to Uganda and you can have much cheaper roaming charges, that's obviously going to benefit trade. Right? If you can go and you can call home and your phone works, and you can afford it, it's going to benefit trade. But right now, the quality is not good, and I frequently, and if not more often than not, I'm making an international call out of Kenya, I would be using WhatsApp, just because the quality is, I find the quality better, and mobile operators moan about the OTTs stealing their revenue by being cheaper, and I just say, well, fix your quality then, because it's not that. So the Smart African initiative has not necessarily done anything about the quality. I think I'll end it on that. But I think they're looking at other services. They're looking at other initiatives that that can happen over the networks. You see a lot of work from Trademark East Africa doing these single stop border posts and other. These are the applications that are going to make a difference in the way we use them.